the one and only Dr. Robert Plomin is my guest in this podcast. It's very hard for me. So to I don't know, to kick back my enthusiastic part, because I really much honor you and your work. And I almost feel like I know you, because you don't know me, obviously, but I read your book like 3 times, The Blueprint. We were going to talk about it because it's the main topic. And it was a little bit different. I'm a biologist by training, so some parts were not that much needed for me, like understanding some basics. But when you think of the implications, and we will talk about it later on, obviously, it opened up more and more for me. And as I have, where do I have the paperback format, which is important because you have it afterward.
Exactly.
Which is very important. And I will ask for you, either some minutes, to give the second afterward, because, some years passed by, and obviously some things might have happened in this field, because this is not static for sure. But for those who don't know you, just once, 2 sentences about Dr. Robert Plomin. I was thinking, how could I phrase who are you in behavior genetics? And I would say like Mick Jagger in rock and roll. For me, you are in behavior genetics.
I'm about his age.
Oh, really? I was not thinking about that, to be honest. I was thinking about, your ideas and some ideas. And I think you had to still be brave to write down some things, what you just wrote down. And this is the part, the rebellion part, where I was thinking, Mick Jagger, coming from England, you're coming obviously from America, from Chicago, as far as I know. But you are a behavior geneticist. You work in London currently, and you've been working there for years at King's College London. And you are now also in London, published like above 900 papers, something. You keep counting it? So a lot, really a lot in these decades. And you are the writer of the book called Blueprint. Welcome, Mr.
Well, thank you very much. It's nice to be here. And I hope that we can get into some really earnest discussion. I would really welcome. I've listened to your previous podcasts, and I like it that you're not antagonistic, but you don't just ask the soft questions. I've done a lot of interviews and podcasts.
Soft questions? What are the soft questions? I don't get it.
Well, the worst is my book just came out in France, Blueprint.
Now,
and interestingly, they don't have the word blueprint in French, so they tell me. So they called it the architect invisible, invisible architect.
I understand. Yeah.
Yeah, and I think that's actually a pretty cool title. But anyway,
maybe better. We were talking about
really nice interviews at L'Express and Figaro, but they were both the worst sort, where they're basically asking me, "Oh, what's your book about?" And then the questions that indicate that they didn't really read my book even. And in a way, it's okay. It's better than like 30 years ago, where it would be very antagonistic and hostile. Yeah. Any interview with the left, any press that was, for the public, basically. So anyway, I'm just encouraging you not to be in awe, and definitely to be tough, and ask.
Okay, but again, it's not about being tough, it's about curiosity in me.
Great.
So this time, and you will understand why. I mean, I will use my environment according my personality. Yeah. And actually, this podcast, maybe it sounds egoistic, is about my curiosity. I really am curious. I want to get the knowledge I'm interested in. I don't know why I'm interested in these things. This is another topic, maybe with some other guys. But when I collect it, I want to share it with the people who will listen it here or worldwide, and a little bit, to think together, because I might have some questions I wrote down here, which nobody asked you. So this is the part. I listened to like 15 podcasts with you, 90% the same, and yes. I should say that like 10% we also need to touch these topics, because we cannot start where I left off, because the listeners will not understand. So we have to bear in our mind that some parts I had to be
sure. And I hope that you will interrupt me if I say things that are not at the level you think your audience is. Do you know what I mean? because
Yeah.
you know that a lot better than I do. I am used to talking to public groups, but it's surprising how much we take for granted. Like for
Exactly.
example, your audience know what a correlation
Yeah,
is.
and this book is for a wider audience.
Yes.
And to be honest, I'm starting to be tough with you, but it's not really.
Yep.
And you know that. Danny
Yep.
Kahneman also wrote the slow the fast thinking. But in the first sentences, I want it to be very easy, and it's not that. So maybe
No,
it's not that
no.
easy to read.
No, it's the best I could do, but but I agree with you. I've heard that a lot. Is that it isn't easy, but I think most people get most of it anyway.
You know how I want to also I try to share it here with my I published 2 books here in Hungary, and I talk to the leader of this company. That I think it's more like 2 books for me, to be honest. The first part is about the DNA matters.
Yeah.
Hey guys, hey people around the world, let's take the spotlight on this one. The DNA matters much more than you think.
Yep.
This is my
Exactly.
first part. The second part is like more about the current and maybe the future options and the possibilities. So we are very much in the DNA revolution in the beginning, like, I don't know, after 1 year of French Revolution. So you don't know where it's going, this time. I mean, you will let us know. So that's why I think that it can be read like 2 separate books. And it's not long. The first part for me, I think, can be read very well and understood very well. And there are those sentences I think most of the people are taking out, and maybe we people don't take that seriously as some, I don't know, some journalists in the media, etc., because these Nazi things always comes up, and I didn't get why. I mean, here in Europe, I know lots of things about it, but okay. Let me back up and start at the beginning.
Good.
If I want to joke, I said, why did you write this book? I will not start with that question, okay? But still.
I'd be happy to answer it, but let's go on to more substantive things. Yeah.
As I wrote 2 books, and I was very fortunate or not, because I could choose the title of my books, and they said, okay. But your title was originally DNA Matters, the essence of human individuality. Am I right?
Yep.
And you didn't really like the blueprint.
No, I didn't. In fact, I knew it would be like a red flag to a bull. That phrase, that it would irritate a lot of people. And it did. Like Matt Ridley, whom I like a lot, he wrote a very nice review, but in it he said the only thing I detest about this book is its title. Because DNA isn't a blueprint, he says, it's a recipe for baking a cake. But in the end, I was persuaded. This is the publisher, and I had this wonderful editor who suggested the title Blueprint.
Yeah,
and it is the a la mode these days. You have a 1-word, a colon, and then a subtitle. Exactly. Blueprint, how DNA makes us who we are. And in the end, I was persuaded by her that was the way to go, even though I knew I was going to get flack for that.
And you got it.
Yeah.
Actually, but I don't want to talk about the blueprint part. I want to talk about the DNA Matters part, which was originally, because I think this will lead us to your very first idea, because I was thinking, who was that famous guy who didn't write or publish the book in the 19th centuries for decades, and finally he published his book, and it was Charles Darwin. And here's a guy who was thinking, I don't know, for 20 or 30 years. And after maybe the DNA revolution, and also the zeitgeist changed that much, that you were thinking that here is the time. So sorry to ask, but I need to ask. So what were your original intentions with this book, writing this book?
Yeah. No, it's an important question. As you say, the first half of the book I could have written 20 years ago. In fact, I was actually approached by a publisher to do that, in almost 30 years ago, I would say, because a lot of this stuff was known by the 90s, the first half of the book. And as you say, these are really big findings that still people don't really understand. The idea that environmental measures show genetic influence, that, just so many of those findings are really big findings. But I felt then I was still, I was a professor certainly, but I was still trying to do research. And I know that becoming writing popular books doesn't help you get grants as a scientist.
I
I think
see.
it works against you. You know, people think, oh, he's just a popularist. And they don't trust you as much as a scientist, I think, because, you know, to write a popular book, you can't, well, you can't lay out all the detail. You've got to, you know, get it down to the nub of the idea, you know. So I decided, no, I didn't want to do it then. I was doing too much research. It was such a hot time because that was just sort of the glimmering of molecular genetics, you know, where we could begin to find differences in DNA directly. And that would be the holy grail, not to just do twin and adoption studies talking about the bottom line of genetic influence, which was very important, but instead actually identify the bits of DNA that account for this heritability. And so that took a long time. It didn't work very well in the 90s, and it began to work in the 2000s, and then it really took off in the 2010s. And so the time seemed to be right to publish a book. And I did want to put the two together because I think they're synergistic. I mean, the first part of the book, a lot of people would have just said, in the sciences, when I got reviewed, they say, oh, ho hum, we've known this for 30 years. But then when you put the DNA revolution on it, that made people pay attention, because you can argue with twin and adoption studies, but you can't argue with DNA. You know, if you actually show bits of DNA that relate to behavior. So it did seem like the right time. And also I was at that point in my career where, you know, earlier on, I thought if you stick your head up above the parapet, you know, someone's going to take a shot at you. Lots of people will. Whereas at this point, I think I first thought the zeitgeist had changed, you know, and I know from talking to public groups, I didn't get any of the hostility I used to get. Now in academia, there's still some hostility. Academia is the front line of the culture wars, it seems, which blows my mind. You know, we're supposed to be free thinkers and, you know, heterodox and all of that. But I was curious as to what kind of reception I'd get, and I got the reception I expected. And psychology is much more accepting of genetic influence than it was 20 years ago. Some areas, though, like education, sociology, you know, I don't know if
Not
they'll ever
yet,
get
but maybe I would maybe argue that maybe also not psychology that much, or psychiatry. We will talk about this one. Can we get to, because you mentioned these laws. Obviously, these are not laws like laws in physics, but laws in genetics. What are these laws that you wrote down? And if you can go one by one, these are not hundreds, obviously. And what are those sentences which, and we start now with the first part, obviously, then we go to the DNA revolution. And why do you think when we talk about this one, these things are not really as a common sense in our everyday life? Why can some things happen like this that we've known this for, I don't know, 20, 25 years? I don't know, Judith Rich Harris wrote some good papers, I think in the 90s, late 90s, something like this, 25 years ago, and we still not live accordingly. So there are two questions: the laws, and what do you think that why we don't really know this? Because this is how I should phrase it, because we don't really know.
And by the laws of genetics, I'm sure you're not talking about Mendel's laws of
No,
inheritance.
sorry, no way. I'm
And,
Plomin's laws of genetics.
okay, well, actually, someone called Eric Turkheimer first wrote a paper talking about the 3 laws of behavioral genetics. And I didn't like the word laws either, but it's taken over so much. These are, you know, well-documented facts, I think.
I see.
You know? Yeah. And in fact, the most interesting thing now is to find any case that violates these so-called laws. I mean, because they're just so well documented. So anyway, the first law that Eric Turkheimer talked about is that everything is heritable. And that's mind-boggling, because in the 70s, when I started out in the field, to say anything in psychology might show some genetic influence was really heretical. I mean, people would get very upset about it. And so in that decade, the bigger studies were done. This was, I don't know, Leon Kamen wrote a book called The Science and Politics of IQ in 1974 that not only said, well, his bottom conclusion was there is no evidence that IQ is heritable. And and there was, I mean, there were science papers
Well,
reviewing
if
the
you look at
literature.
psychology in the 70s, the behavioralists were still here.
Yeah.
So, so even
And
in that part.
And unfortunately, behaviorism, which started in the 1920s, and I think took up there were first twin studies were done in the 1920s, but then with Nazi Germany, there was a void and you couldn't talk about genetics for several decades.
Mhm.
And I think that void was filled with behaviorism, the view that we shouldn't just be introspecting about how does our mind work, although we've come back to that in a big way now in
Yeah.
contemporary psychology, but to focus on observed behavior. And then the laws of behavior, reinforcement, extinction, that was all a good thing to do. But it got associated almost by accident with environmentalism. Because how do you change behavior? Well, you look at rats and you study their behavior, and then you shock them and you show that you can train them to do something.
Mhm.
But that's an environmental intervention. And they didn't believe in genetics. Skinner had there's the most famous figure, is where he shows the learning extinction curve of 3 different species, primates, mice, and humans, but he doesn't label them because he says the differences aren't important.
Mhm.
What's important is all these species learn the same way. So environmentalism was so strong. When I remember, I've tried to look this out. I can't find the book, and I didn't want to waste much time on it. But I read in textbooks in graduate school in 1971 that schizophrenia is caused by what your mother does to you in the first few years of life. A lot of the environmentalism in psychology, in developmental psychology especially, was mother blaming.
Yeah.
Because that's basically what Freud said. Freud said, people say Freud was biological. He wasn't really. I mean, he was mostly pinning problems later in life on parental behavior, breastfeeding, toilet training, stuff that we now know has no effect on later adjustment, Yet somehow that was the good thing. The environment had the white hat and genetics was the black hat, it's bad. Now, if you think about that, you're like, well, why is the environment so good? I mean, the idea that people they don't differ, they're all the same, is in a way the justification for Stalin and Mao and North Korea.
Yeah, they banned in the Soviet Union, genetics was not something that you could do. So
Yeah,
the
that's
famous
right.
guy Berdyaev worked in Siberia somewhere there, and he didn't call it genetics.
Yeah. So that was quite a monolith to turn around, this environmentalism that was so dominant in psychology. But then to go in a decade from saying, well, maybe this trait's heritable, maybe that trait's heritable, and you get more and more evidence, to saying, like in 1990, everything is heritable. Everything we study shows genetic influence on individual differences in any trait in psychology. So, I mean, that's a mind-boggling finding to change, to go 180 degrees from saying nothing's heritable to saying everything's heritable.
Yeah, and if I may interrupt you, it's interesting because nobody says that these guys like Skinner, etc., they were stupid guys. They were not. So obviously, so they were very clever guys. So I don't like when we always, say it to the, 100 years ago, they were not that clever, etc., because that was a different era. But as history was there, obviously, the Second World War and what the Nazis did, etc., it was important. But I think when you talk about behaviorism, environmentalism, it's also connected to control, right? That you can control your life. And if somebody is lazy, if I may say, cannot do or cannot reach, I don't know, to become a professor at the university, that's because of his laziness, etc. And this cannot be connected to any other basic like genetics background, which, to be honest, partly was my thinking too for some decades. Not that black and white, to be honest, but I didn't get, for example, I have an older brother, why he's behaving totally differently as I do, as we have the same parents, for example, and you mentioned this once, and I'm now jumping a little bit to the end of this one, but Dr. Plomin, I have to confess you that this book made me more tolerant.
That's what I hoped. I actually say that at the end. That's such an important point that people think, oh, genetics means you're a right-wing bastard. It doesn't at all. It's just, I think the larger issue, stepping back from all these things you've just raised, is I believe science leads to facts, and it's an old-fashioned view, but that you can interpret. There's no necessary policy implications. It depends on values, but we ought to be able to agree on facts. If I show you all the evidence for everything being heritable in psychology, you can disagree. You could say, well, what about this? What about that? But then at some point, it's just overwhelming. And I hope we can just accept that and say, okay, that doesn't mean you have to be a right-winger or anything, Then the second thing I'd like to say in terms of what you just said, so the first point was no necessary implications, policy implications of finding genetic influence. But then the second thing is that we can change behavior drastically with the environment. We're talking about individual differences in behavior.
Very important, yeah.
But if you can, with North Korea, I believe people have really, if you have a totalitarian government, or even Stalin or Mao, and given a totalitarian government, they can really make people conform. But I think deep down, you still think of 1984, and there will be people who rebel and who are different. But anyway,
so when we talk about the basics, so just in one or two sentences, they were twin studies and they were adoption studies. If you can elaborate these parts, how did we get to that knowledge, the genetics, the DNA, if you like, matters much more than we think. And I think this is astonishing, really fantastic things that you just got out from these topics.
Good. Right. Well, the basic data for the first half of the book are, as you say, twin and adoption studies. Not to do with DNA, but when we talk about genetic influence, we're talking about inherited DNA differences, but we're not measuring them. So here's how we do it. The twin study is like a biological experiment, quasi-experiment, and the adoption study is like an environmental, social experiment. So in the twin method, people probably know there are two types of twins, identical twins, who really are, now that we can sequence DNA, genetically identical, despite what some people say. They're identical in terms of the inherited DNA differences.
Close.
With which they began life as a single cell. The other type of twin is like any brother and sister who happens to be born at the same time. They're called fraternal twins, or in England, only in England, they're called non-identical twins.
Interesting.
But they're 50% similar. 50% similar genetically. So if you take a trait, like a trait we don't know much about, musical ability, kids differ in their musical ability. If you've ever seen a kid who's gifted musically, you almost just have to stay out of their way. You don't have to give them the world's best tutors or anything. You almost can't stop them from being musical, especially now in a world of online Spotify's and that sort of thing. So if a trait like musicality, however you define it, measure it, is heritable, you'd have to predict that the identical twins will be more similar for that trait than fraternal twins, because the identical twins are twice as similar genetically as the fraternal twins. It doesn't mean the fraternal twins correlate 0, because they're 50% similar genetically. And so when we took, and then the other method is completely different. And there are assumptions of the twin method. But the neat thing about the adoption method is it's completely different, has completely different assumptions, and yields the same conclusion, which I'll get to in a minute. And the adoption method is where, people forgot that in families where parents and offspring and siblings share genes as well as environment, you can't assume that what runs in families for environmental reasons. It's reasonable to think that, but everything runs in families, schizophrenia. And for decades, a century, people assumed, that's environmental. It's the way the parents treat the child early in life. So that's nurture. Fine.
Yes.
It could be.
Nurture. We didn't mention the nurture and nature,
That's right. And nature is the genetics, and nurture refers to systematic effects of the family environment, especially parenting. As you said, you and your brother have the same parents. Exactly. And so they could treat you differently. But, on the whole, if your parents are very physically punitive and authoritarian, they'll probably be that way to both of you, you know.
Thanks God it was not like that. Yeah.
Yes. So the way you can separate that nature and nurture is through adoption, where biological parents or birth parents relinquish the kids for adoption at birth. And in the past, not so much now, but when I was doing adoption studies in the 70s and 80s, you just gave the child away at birth, and I don't know if you had to sign something saying you would never try to make contact with the child, but there was no contact between the child and the adopted away child. So if the nature is important, you'd predict, well, they still share 50% of their genes. So they ought to be similar, even though they didn't share postnatal family environment. And then the other side of it is kind of cool too, because you've got the adoptive parents of those adopted children who share the family environment. They adopt the kid in the first few months of life. They raise that kid, but they don't share genes with that kid. They're not genetically similar to that kid.
Yes.
So that would be a test of nurture. So the adoption design is nice because it takes nature and nurture, which is confounded in normal families. I say normal, it's not, there's no good word for it. I don't mean adoptive families are not normal, but you know what I mean, that they share genes and environment. And then you've got the birth parents with the adopted away kids who share genes but not environment. And then you've got adoptive parents with their adopted children who share environment, not genes. So if you take weight, I don't know if people know, people are often, they're not surprised to hear height is highly heritable. And for like maybe 80, 90% heritable in most countries that have been studied. And that's because, say, identical twins correlate about 0.9 and fraternal twins correlate about 0.45. So both of them are about as similar in weight as they are genetically.
Yeah.
Okay. So that's, you can estimate.
0.5 is for fraternal part is like the heritability here.
Well, 0.45 is less than 0.5.
Yes.
Which is their genetic similarity. 0.9 is less than their 100% genetic similarity for identical twins. So by dividing, if you compare those two numbers, 0.9 and 0.45, the difference is 0.45. Yeah. And that only represents half of the genetic influence, though, because you don't expect fraternal twins to correlate 0. You expect them to correlate 0.5. So anyway, you double that difference and you get 90%. That's where the heritability is.
Yeah, it's clear.
Right. So people understand, they accept the idea that height is heritable. But what they don't often understand is that weight is very highly heritable. Not as high as height, but it's maybe 70% heritable. Now, what that means is of the differences in weight between people, that in the population that we study, 70% of those differences are due to inherited DNA differences. It doesn't mean this is a trait close to my heart, close to my stomach, actually, because you know,
I know. You know what you are talking about here, right?
Yeah, I have a genetic propensity towards weight, and there's a new twist on that story I hope we get to talk about. But if you do the twin studies of weight, you find, say, in adulthood, I mean, not babies, it's a little hard to study. You could, you know, it's less, well, anyway, if you do it in adults, just to make it a simpler story, you find that identical twins correlate about 0.75, something like that, and fraternal twins correlate about 0.35. So you double that difference and you get about a 70% estimate of heritability. Okay, so now if you go to the adoption design, parents and offspring correlate about 0.4 for weight.
Yes.
And this is BMI, body mass index, weight corrected for height. So is it nature? Is it nurture? So if it's nurture, we'd expect the adoptive parent's weight to correlate just as much with their adopted child's weight.
Adopted child, right? Because they live together in this, they eat almost the same cuisine, etc., the same habits, right? So this is why
and the parents model lifestyles as well, how much exercise they do, how much they're concerned about weight, for example. But the correlation between adoptive parents and their adopted kids is 0.
This is the part where we would stop for a commercial break, but we don't have here a commercial break because this is, I think, a very important part.
But the other shoe has to drop, and that is, if that's true, then where does that correlation of 0.4 come from? Well, it ought to be genetics, and sure enough, biological parents and their adopted away children correlate 0.4 for weight. They correlate just as much as parents who share environment with the kids.
Well, I think this is, you were talking about the mother blaming. I think there is also parent blaming these years. That everything is, we do everything, and if something happens, that's because of us. If something doesn't happen with our children, that's also because of us, you know. And sometimes I also have this quarrels with my wife, to be honest. Believe me, are you all talking about your plumbing thing? So to be honest, I think in 2023, this is still not that clear for the majority of the people. I'm sure, because what you just say this time, that, and we need to get a little bit to parenting part, how much parenting matters. This is one of the maybe crucial sentence in your book, that parenting counts but doesn't make a difference, or something like this.
Yeah, parents matter, but they don't make a difference. Those 4 pages have gotten more attention than probably anything else in the book. So much so that the publisher offered me a contract to write another book.
But you didn't do it.
I got a big advance to do it, but then in the end, I decided I didn't want to do it. I mean, it really needs to be done. There are thousands of books on parenting. They hardly mention genetics.
Robert,
it drives me nuts, because I think the single
sorry for
most...
interrupting. Before I heard your sentence, you were talking about this in one of the podcasts. And when I stopped here at your book, I was thinking, somebody should write a book for the wider audience. Oh my God, if I would be that type of person, but also not interested in that, you know, in that, not that detailed book.
It made it,
you were writing that, yeah.
Yeah, I mean, it needed to be written, but there were 2 things that stopped me. One is someone else in my field said they were writing a book like that, and I won't mention it, but it turns out
it's not that good.
It's not good. It hasn't gotten any attention. And the second reason is that I took to heart what you were saying about Blueprint being not an easy book. I mean, you know, but when it comes to a parenting book, they really demand a much lower level of presentation. Exactly. And it's always like, you know, when my kid crapped his pants in the middle of a concert, or, you know, you have to talk about, well, you got to be much more human than I'm prepared to be in a book. Well, you know,
I think you're human too, but we can say that if you're good at academia, for example, it doesn't mean that you are a good journalist or science writer. So there are some people who are good in both fields, for sure.
Yeah, like Emma Duncan wrote this wonderful book on crib sheet. You know, she's an economist. She was a main editor at what's that? The main popular, The Economist. You know, that journal. And she wrote it as a mother. Then she started looking around at these parenting books and said, "Where's the data? Where's the evidence?" You know, it's always like authoritative. Dr. So-and-so says this, and you say, "Yeah, but what's your evidence for that?" And so she wrote a book called Crib Sheet, which is in English it's the idea of cheating on a test. You get a crib sheet, but it's also a clever name because of the infant crib, right? And so in her book, she looked at all the evidence, and in the end, she said the only thing you can say for sure from in a parenting stuff is vaccinate your child. She's saying all this other stuff about what do you do if your kid doesn't sleep. What they're not taking into account is individual differences in the parents and in the kids. But she doesn't get to genetics. So I'd actually tried to, she'd be just the sort of person you're talking about, you know, a journal.
You know, I'm wondering, because
there's still enough negativity about genetics.
Yeah, but we need to, when we say a sentence like this, what you mentioned, I would follow for really just 2 minutes for this part. Okay, I am a parent too. So, you know, how should I take this one? Offensive, defensive, you know, how is it talking about me as a parent? And I was thinking that, of course, we're not talking about abusive parenting.
That's right. That's
neglecting, very important. So it's also dimension, obviously. But when I see other parents, I need to kick my daughter or son to learn. I will not buy him or her this and that because he is not studying. And if I look back to my life, and this is the data shows me what I wanted to learn when I want to have a podcast like this, nobody's, giving me sticks, or I don't know, kicking me to do this one, because I do it out of my own interest.
Exactly.
And obviously, fear can move people. I don't know whether it's true or not. Napoleon said that there are two things. Two basics can be like why you do anything, out of fear or out of interest. I don't want to live because of fear, that I'm fearing things stuff like this. But please give me also information, data. Of course, this can be some 1,000 pages, but when you think of parenting, what is our job? You're also a parent, you're a grandparent too, you have your grandchildren, etc. So what do you think that we should do, and what are the things that we should not that much bother, if I may ask this question?
Well, that's great. That's the main reason I like to do these podcasts, because not everyone's interested in the conceptual issues as you are and as I am. That's really what drives me on it. I don't do science because I want to fix the world's problems. I mean, I hope the work I do has an effect, and I believe it really does.
Yes.
But that's probably why I couldn't write the parenting book, because then you have to go on the other side, but anyway.
At least you know that you should not write. Some people should have known not to write some books.
Yeah, maybe that's right. And also at this point in my career, I want to do things I want to do. Like you said, interest, and I don't know why it doesn't interest me, because it ought to, as you're pointing out.
Yeah.
This is a really important topic. Someone ought to write a book on why parents matter, but they don't make a difference. That is why, starting with the fact that genetics is important. So in answer to your question, like what should parents know, what should they do and not do? The first thing is to recognize they have much, much less control than they think. And that's for two reasons. One is genetics accounts for most of the differeses. 70% of the differences in school achievement are due to inherited differences. 70%. Now, that's not 100%. And the first law of genetics is everything's heritable. The second law is everything is not 100%. Nothing is 100% heritable. And that's important. It's not all genetic. But then the second thing they need to know is that the environment works very different from the way we thought it worked. It's not nurture. It's not systematic effects of what the parent does. And people find that really hard to believe, but in part because of the third finding, and that is that what we call environment is often genetic. It's genetics in disguise. So when parents, it drives me nuts, like in the paper, where we all know correlations don't imply causation.
Causation, right.
But when you see something where parents who read a lot to their kids have kids who read better when they go to school, okay, just ask your audience, what does that mean? How do you interpret that? And it's almost hard to resist interpreting that correlation causally, to say, sure, parents who read a lot to their kids make their kids better readers. But once you recognize genetics, you can say, well, but wait a minute now, these parents differ genetically. Why do some people like to read to their kids? Why do they have lots of books in their home? Is it magic? It's genetic differences that account for that. A lot of that has to do with educational achievement and cognitive ability and verbal ability.
Yes.
So if you accept genetics in terms of the parents, what about the kids? They're genetically related to the parents. So couldn't it be that correlation is actually caused genetically because they're 50% similar genetically? And then on top of that, I would say, as a grandparent, I see this more and more, it's not neither of those. It's that parents are responding to genetic differences in their kids.
So it's a reaction.
Yeah, well, it's just like, like I have 6 grandchildren, and one of them, I always thought as a grandparent, kids ought to sit, you want to read? Yeah, sure, granddad, I loved, I thought that's what grandchildren are supposed to do. 5 of my grandchildren, they don't want to do that. It would almost be abusive if I made them, you sit there, I'm the grandparent, I'm going to read to you, you're going to enjoy this reading because you're a grandchild. But they want to go out and kick a ball around. They're more active. But this one grandchild, she would sit there all day and let me read to her. She's also very verbal in the sense she wants to know about nuances of words. Why did you use that word rather than that word? So who's going to develop the better vocabulary? Who's going to be a better reader? It's obvious. But I think it's as much me responding to her as it is her genetic differences. And that's a topic we call nature of nurture. The idea that the way genetics has its effect on behavioral development is through the environment, that is selecting and modifying and even creating environments correlated with your genetic propensities. It goes back to what you were saying about interest. I think it's much more a matter of aptitude, of appetites rather than aptitudes, you know? So if you've seen a musically gifted kid, you really see that. As I said, it's almost hard to stop them from being musical. You can't stop them from humming or thinking about music in their heads or, listening to music. So I think those are very important lessons for parents, because it all comes down to saying you don't have as much control as you think you do, because the environment doesn't work the way we thought it works. It's not nurture. The environment's important, less important than inherited DNA differences, but it is important. But it's not these systematic effects of parenting. Whatever it is, it's making two kids in the same family as different from one another as kids in different families, as we saw in that example of body weight. Growing up in the same family with someone doesn't make you similar. Those systematic effects of nurture can't be important. So
it's very hard to accept.
it is, but it ends up being chance, which is getting to be a hot topic in physics and even economics. We think everything has to be systematic, but I think, having looked for 30 years for what causes two children in the same family to be so different, we're not coming up with anything. And so you don't like to just accept the null hypothesis, but which Eric Turkheimer called the gloomy hypothesis, or maybe I called it the gloomy hypothesis early on. But, and I thought, well, no, you got to really try. Take all the measures that are around environmentally, parenting, anything, peers. Judith Harris, in her wonderful book, The Nurture Assumption, said, well, duh, you guys can't find the non-shared sources of environment because you're only looking in the family. What's important are peers,
right? Yeah.
But they're not. I mean, the same sort of thing. The peers a kid hangs out with, like whether they're academically oriented or jocks, athletically oriented, or druggies, they have an effect. There's a correlation between your peers and your behavior as an adolescent. But again, it's a correlation. And once you understand genetics, you don't just accept the simple explanation of, well, sure, the peers cause the kid to behave like that. Having these druggy friends causes the kid to be delinquent, for example. But what about genetics? And I hope people are getting a glimmer of the idea that, well, kids differ genetically. Some kids are more actively genetically oriented towards academia. Some are more into sports. I mean, just because their bodies they get rewarded for doing sports.
Yeah.
So it could go the other way, that kids are selecting peers who are similar to them.
Choosing their environment.
And choosing their environment, yeah. And modifying it too. So if you hang out with kids who have a tendency towards delinquency, they get together and they have this synergistic effect saying, yeah, sure, let's go in this store and rip off everything we can rip off, shoplifting. So
this all thing for interpreting you, it is going against the Western kind of thinking that everything is up to you. You make your fortune. If you don't do it, then it's again your fault. And when you have your children, again, this notion, your children.
Exactly.
Yours.
Right.
They are separate beings who need your taking care of them, obviously. But later they are separate beings, partly like you, but they are not you. It's very important. I mean, the parent as myself. And this lack of control, for some people, it might say, oh God, then maybe it's not that a big idea, not big deal that this afternoon I didn't go to that match or took him or her there out, because everybody's doing it here in Hungary too, to be honest, that we want to give the best to our children. But for some people, not having control can be a problem because we have different personalities, right?
Yeah, this is the critical issue, that you want to do the best for your child. But why? Not because you want to make them into what you want them to be. Like you don't take them football practice because you want them to be a professional footballer. You take them to football practice because they like to play football. You think it's fun for them. You do things for them because you love them. You do the best for them because you love them. You don't do it because you're trying to make them into what you want them to be.
It's
It's
clear,
such
but
an important point.
nobody is idealistic. So this sounds very idealistic for me. But we live together in a society, also in Hungary. You know, you park here, the other parks there. We see what the others do, and we act accordingly. We don't want usually, you know, to be very different. So it's very important. This needs self-reflection, what you mentioned, that what I want to do, I don't want him to be a football player I couldn't be. So it's not my dream. And as far as I know, well, I see, because I work with athletes, usually people are not that clear with their own ideas and thoughts. I just want to give the best for him. I didn't get it, so I give them. Did they ask for it?
And that's great. You say that's great. But why are you doing it?
Yeah.
And if you're doing it because you think you see all these other kids playing football and they like it, you'd encourage your kid to play football. Now, I had actually, my wife was a developmental psychologist who studied siblings, Judy Dunn, and the reason she got into this area is because she had fraternal twins, and these two boys are as different as two people on Earth, even though they share 50% of their genes. One is tremendous at sports and always was, even from a little kid. You know, you could tell early on, and he's 50, but he's still playing, not semi-professional, but, you know, playing serious football.
Oh.
And the other one, you know, it looks so different, didn't look like an athlete, but also just hated it. Didn't like sports. You had to kind of force him to do the team sports at school because they make you do it, you know? And so I think recognizing these differences between kids and thinking that your job as a parent isn't to make them into what you want them to be, but to find out what they want to be. Help them become who they are genetically.
Giving them, opening the world, giving opportunities.
Exactly right.
As a parent, right? So this is.
Yeah. Find out what they like to do. And that means exposing them to different things. And the trade-off is, you know, you can't be a dilettante. You have to, like, how do you know if you're good at football? You can't just play one afternoon. You know, you need to develop a certain level of skill to be able to tell whether you're going to be good at football and whether you like it. And they're interrelated. I mean, if you're uncoordinated and just not athletic, it's going to be really hard for you to become a top-notch footballer. Now,
why?
You can,
Why
again,
would I?
well, exactly right. That's the point, you know, that it's not to say you couldn't, you know, with enough coaching and a father who's determined to make you into a good footballer, you can go pretty far, but you're not going to be a professional footballer.
Yeah,
you know?
I'm totally with you, and I totally understand and hope that people will also understand. But I'm curious from my biologist perspective. If you step back and you talk about the human species, I sort of understand why we don't have that big control over things, because there's a reason for that. And I'm thinking on evolutionary terms here. Of course, I don't wake up in the morning, okay, I start my liver now, I start my heart, and this is how we go on, because otherwise I would forget it maybe on a Monday and I'm gonna die, you know? So there is a reason that some part of ours is conscious and the biggest chunk is not really conscious. So, and please give me your ideas that what could be, maybe we just speculate on this one, this is out of your field. What could be evolutionary accounts for this?
Yes.
Why is it like that?
No, it's a well-studied phenomena in genetics that it has to do with genetic variability. It's like money in the bank for a species. If we were a species who was perfectly adapted to a very narrow environment, there wouldn't be much variability because it's not adaptive to be variable when the environment is a constant. But humans, probably more than any other species, except dogs, for example, which also is a bit like humans because they're commensal, they grew up with, you know, they evolved with humans. Most species like us, what we're good at is operating in diverse environments. And so genetic variability is adaptive for us as a species, rather than saying more is better for everything. So we're not all adapted to be exactly one height, because that isn't adaptive particularly. It's probably, as we know from our evolutionary past,
Yeah,
sometimes it was good that we were short and sometimes it was good that we were
nobody
tall.
could see us, right?
Yeah. But there are some things that are so important for us as a species, there's not much essential variability, like walking on 2 feet,
Mhm.
and also frontal vision, which requires eyes in the
Yeah,
front of
but you
our head.
cannot see what's happening behind you,
Right.
right?
It's a cost, a real cost, right? And, but we're predators probably. That's what predators have, is they have frontal vision
Yes, yes.
because it gives you binocular vision, which is tremendously important for picking out that monkey or something in a tree, So there are some things that don't allow for much variability, but actually even there is. I mean, we all walk on 2 feet mostly, but there's big differences in how we walk on 2 feet, differences in gait, and certainly when you get into running and things like that, there's huge differences between us that can really make a functional difference.
Ladies and gentlemen, it means that it can happen that for some of us, life can be harder, for example, with lots of, I don't know, um, I'm neurotic, much more neurotic than the most of the people, and that's not good for me, but maybe for our species is good in some situations, that I can see that the danger is coming from there, etc. So the danger is coming from back around. If somebody tried to open the door, I was just joking this time. So on the species levels, let's go to the next topic. We were talking about your laws you were mentioning, and what I want to hear a little bit, just to talk about the quantitative versus qualitative idea. You mentioned abnormal is normal. Am I right? Can we a little bit open up that topic?
Yeah, and I think that's another great topic. It's also a little harder for people to understand, but I think it's very important. It's changing psychiatry and medicine to some extent. And the bottom line is that when we talk about heritable influence on, say, schizophrenia or bipolar depression or any of these other traits, we're not talking about one gene. It's really hard for people to get that, because they learn about genetics from Mendel, which is a single gene sort of approach.
Yeah.
And Mendel figured out the way genes work. But the thing is, Fisher in 1918 had this famous paper that was the basis to what we call quantitative genetics. And that is that if every gene works just like Mendel said, but there are many genes that affect a trait, then instead of having dichotomous categories, like if you were a pea plant, whether you have smooth seeds or round, wrinkled seeds, instead of categories, it's a continuum. It's this normal bell-shaped curve.
Like a
And this is
height.
yeah, everything, all of these traits and common disorders, things that we pretend are categories, like obesity or high blood pressure. I mean, these are continua, and the genetics operates continuously. So it's a matter of more or less rather than either or. And that's the idea then, that taking it to the extreme, there's no such thing as a disorder. We're
Second
pretending.
commercial break. When you see this, there's no such thing, no ADHD, no schizophrenia, no.
Yeah.
Again, something very important. Yeah.
Yeah, it is. But what the main thing is, what's to be gained by pretending that these continua are etiologically distinct? Because that's the medical model, and it works very well. With COVID, there's a single agent responsible for whether you have COVID, and it's necessary and sufficient. So once we knew it was the SARS-V2 virus, you say, what happens if you're infected with the SV2 virus? You get COVID symptoms. People who truly have COVID and not something else, they have SARS-V2 virus.
Yes.
Necessary and sufficient. And the same thing with thousands of single gene disorders. You either have it or you don't. Like Huntington's disease is from a mutation on the tip of chromosome 4. If you get that mutation because it operates dominantly, you only need one copy of it to show it, you will die from Huntington's later in life. after 20 years of neural degeneration, you know, and it doesn't matter what your diet is, doesn't matter what you do, you're going to die from it. It's necessary and sufficient. Now, the problem is people think that when you say genetic, that's what you mean. Deterministic, hardwired, nothing you can do.
Yes.
It's true with single gene disorders, but it's not true with the common disorders or complex traits that we deal with. They involve thousands of tiny DNA differences, and that makes them probabilistic rather than deterministic. And that's why we're dealing with continua. We're not dealing with categories. So I say there's no such thing as schizophrenia. There's no such thing as autism, no such thing as ADHD. What we're doing in psychology and what's held us back is the medical model, assuming that there's one cause. If you've got cholera, why have you got cholera? Well, that was the beginning of epidemiology to say, it's if you drink water that's infected,
Yeah.
you'll get cholera. So that's the medical model, to say, here's a disease and what is the cause? Now, the problem, though, is even medical people know that most of the common disorders, most of the things that create a medical burden in society are continua.
So,
Now,
sorry, don't you think that it's not a medical model, but is the way of our thinking and language use? Because you don't say, you say red, you don't say 440 nanometers, you know? Because we're thinking categories.
Yeah, but red isn't a category. Red is a continuum.
Yes.
Importantly so. And it's a good example, you know, where we talk about differences between people, like ancestral differences, ethnic differences. The problem is talking about it as a category.
Mm-hmm.
Just like, you know, I don't think anyone would disagree. People differ in hair color. Your hair color is black going gray. Mine's gray.
Yes.
There are redheads, but are we saying they're a category? They're a distinct category? No. You know, there's every shade in between. But you'd say, yeah, there's some variance in hair color that's explained when we say that person has red hair and that person has blonde hair.
Yeah.
So there are these groups. And with disorders and diseases, it's not to say there aren't problems with losing touch with reality in schizophrenia, or being paranoid, or having high blood pressure, or having problems with reading. These are all problems, but they're the ends of a continuum. And that's a very important distinction, because again, it brings us back to tolerance. It's not us normal people versus those crazy schizophrenics.
We are all there. We are all there on the continuum.
We have thousands of genetic risk factors for schizophrenia. We're just not way out there on the extreme. And so I think it leads to kind of a tolerance and acceptance with weight, which, as I say, is one of my problems. Because my highest, we haven't gotten into polygenic scores, but one of my highest DNA risk factors is for weight. And you know, people are intolerant. They assume it's environmental. We've already said weight is highly heritable. And what this means is I have a genetic propensity to put on weight more easily. Now, I don't know what the mechanisms are, but in psychology, we know there are two, and they're both true for me. It's called satiety. After you're full, normal people would say, oh God, I couldn't eat anymore, I'm full. Well, I can go out to dinner with people at a restaurant and say, oh, I'm full, everybody's full, but there's food on the table. And as we continue talking, before you know it, I've eaten it all.
And I know people like this.
Yeah.
So you can't help. You can't help, right?
Well, you can help. You know, that's the thing.
You can.
But what you were talking about is, on average in the population, you know, people would say, just pull up your socks, don't eat like a pig. But that's easy to say if you're skinny and you don't have that urge to keep eating. And the second factor is equally important, and that is the food responsiveness to food cues. I used to bake bread, but the smell of baked, it makes my mouth water even now just thinking about it. When the smell of fresh made bread, and the thought that while it's still warm, you could put butter on it and the butter melts, you know.
I'm getting hungry now, so please stop.
It's really watering thinking about these things. So I'm not saying, oh, it's not my fault, but in a way, it is my genetic propensity that I can put on weight more easily than people because of these behavioral faults that I have, but also it's harder for me to lose weight. And so that leads to, instead of fat shaming, which there's a lot of, I don't know in Czechoslovakia, but in England, they're really talking about treating it like smoking or something. If you're fat, It's your fault. And, being fat is a real medical risk factor. It's probably almost as bad as smoking in a way, because it affects cancer, it affects heart problems. It has a lot of effects. So the idea is, why are we fatties burdening the health system? Because it's our fault. Why don't you just, take control of yourself and lose weight? And the thing is, you can stop smoking, but some people do find it a lot harder than others.
A little, or not just a little, but it can be the other way around. So I can't help. This is my genetics. This is how I am. I'm going to eat like a pig. That can be also an answer, right? The other way around.
That's what people worry about. But I say that whenever I think about these things or talk to people who have done their DNA testing, like with one of these direct-to-consumer companies, like with weight, it's made me feel like I'm in a battle of the bulge, for life.
Yeah,
And
yeah.
it's not just Christmas, the weight I put on at Christmas. It's like every year, it's an extra kilo or 2 kilos. It's slow, invidious, and I find it very motivating to say, okay, I've got a battle here. I got to control my environment so that I don't make it so that late at night when I'm tired or feeling ill, that those snacks in the cupboard start talking to me. And you say, well, there's a bag of crisps. I'll just have 1 or 2,
Yeah.
I'm feeling kind of down, so I'd like a little hit like that. But then before you know it, the bag's gone. So simple thing, environmentally manipulating my environment.
Don't buy.
I don't have snacks in the house. I mean, I don't have, we call them cookies in America. You just don't have sweets around, because most of the time I can say, no, I really shouldn't do that. But if it's just sitting there.
Yeah. But I have to give my thoughts on this one. Not everybody is like you. You know. So, and we are a little bit talking about the knowing or not knowing part.
Yeah.
Whether knowing is good, you're mentioning it's good. So because with the knowledge, you can a little bit, make your environment different, control your environment, that you don't have, these problems, what you mentioned. But not everybody is like you. And I'm not sure, maybe I'm a little bit more pessimist, but usually they say I'm optimist, more pessimistic, but maybe this kind of knowledge can be not that good for everybody, for example.
Yeah.
Can interpret it in a very different way. And I'm not sure which would be the best. And there are some reasons that we don't know, for example, originally, what's in our DNA. Don't you think?
Well, I think that's possible, but I'm just saying empirically, people I know have done their testing, they do tend to respond the way I responded. For example,
choose your environment, Robert.
Instead of just saying, oh, well, eat, drink, and be merry, I'm genetic fatty, nothing I can do about it. Well, that's wrong. It doesn't mean there's nothing you can do about it. It just means, given our fast food nation and the fact that we have Stone Age brains that evolve to get fat wherever we can, right? Because back then you didn't know when your next meal would come. So it was very good to store fat. But now, of course, that's our problem is, once we start feeling like we're starving ourselves at all, which just means not eating like a pig in my case, your body starts storing fat. It's actually counterproductive to losing weight. There's a lot that's known about this sort of thing. So what about something like alcohol? What if you found out your kid had a high genetic propensity to alcoholism? Does that mean, are you going to tell your kid, oh, well, you're going to be an alcoholic, so what the hell, just enjoy yourself? No, you'll say.
But you will think, oh my God, he is drinking now the first beer. What will happen now? And you start, because you're the parent.
That's right. So you could say, well, just keep him away from alcohol. You cannot become alcoholic if you don't drink alcohol. But I think the first thing to say is, it doesn't mean you're going to become alcoholic. It only predicts like maybe 10% of the liability to alcoholism. But we could say, this is useful information. If you go out and drink with your adolescent buddies, and get blotto, you're increasing your risk for alcoholism and becoming, not addicted, but, just dependent on alcohol to a greater extent than your buddies.
So it reminds me the importance of for the people to understand what we are talking about, because it can be, just tiny differences, and we are not on the same side. So that it's very
That's right.
important.
It doesn't mean that your kid has one drink and then just keeps drinking until they're blotto and alcoholic. No, it takes a lot of alcohol over a long period of time. It's just like getting fat. It's invidious, little bits at a time. You drink more and more, you become dependent on having a good time by being drunk, and then you get to the point you need alcohol in the morning to get yourself going. That's the way it comes. It's a decade process. It isn't just like suddenly become alcoholic. So if you knew you were at genetic risk, it would seem to me only reasonable for you to say, I'll pay more attention to the messages we all have. Alcohol is one of the worst drugs around. If you look at an alcoholic brain after post-mortem, you don't need a microscope to see this brain. It looks like someone threw battery acid at it. It's got big holes in it.
I have a feeling that it's really not alcoholism. It's a kind of solution for your problems, and it's not the alcohol, but it's very thousands of years. This is how we solve some problems in our lives. I think there are deeper things behind alcoholism. So this is how we call this solution making, if I may say it like this. But we should not go to that depth, as we don't really have too much time. We have like 8 minutes or so. Two things I really want to touch here, and I see we cannot get there where I wanted to, but this is how discussions go.
Let's make a deal here that I've enjoyed talking to you so much. Why don't we wait to see what the reactions from your audience are, and maybe down the line we could have a follow-up conversation.
Fantastic. This is what I wanted to suggest in the end, but you suggested it, so it's fantastic. But still, for that 7 minutes, I need to ask these things. First of all, what happened in the last 5 years, that maybe made you, or you were thinking that I would change something in this book? Is there something that you would change? Are there, of course, obvious new things? This is the first part I want to talk about. And the second one, your future plans. Maybe the future plans can go to the next part, because that's okay. It can still wait. But
on the first part,
because you mentioned for me that there were some interesting facts that maybe happened in the last years that's not in the book, and maybe worth talking about.
Well, before we started recording, we mentioned that the paperback of the book is actually better because it has an afterword that talks about my reaction to the book. Exactly. And there's more along those lines, but I think your question now is more about science. What's happened, what's changed in science.
Yes. Sorry, I didn't rephrase it correctly. Yes.
The book has what's happened. I just wrote something called Celebrating 100 Years of Behavioral Genetic Research, and it was just published. I think it'll be published this week or next week or something like that in the journal Behavior Genetics. And in there, I talk about these big findings from the 90s in quantitative genetics, twin and adoption studies. And what's happened in the last decade or so is they've gotten many different methods to get at it, more sophisticated approaches, but basically it's all yielding the same sort of conclusions. It's sort of firming it all up. And you can't now, a graduate student who wants to do a study saying, no one studied this trait, let's see if it's heritable. You say, don't bother, it is. You've got to ask more interesting questions about development, multivariate issues, how things relate to one another. One of the findings we didn't get into is generalist genes. The idea that genes don't work in a one-to-one way, that because there's many genes involved, they operate very diffusely through the brain. So as a result, then they have the same genes. All genes affect a lot of traits, is what that's about.
It's very complex. It's very complex and complicated.
Even
Nature was just thinking about our mind.
So what's happened in the last few years is that the quantitative genetics has gotten strengthened in itself. But the big news, and what my paper Celebrating 100 Years of Behavioral Genetics is about, is that the biggest thing is the integration between behavioral genetics, which we call quantitative genetics, like twin and adoption studies, and molecular genetics, the DNA revolution. By putting measured DNA into these designs, it's the next level for sure of analysis. Fantastic. And we're finding out a lot of interesting things by incorporating, say, DNA studies with these twin and adoption studies.
Well, Dr. Plomin, this is a fantastic trailer for our next discussion, because in the last 1.5 hours, we were talking about why DNA matters in some, I think, important topics. So as you mentioned, I will use this chance and we will get back to this topic, and we'll see what people say about this and how they react to this one. So thank you very much for your time. It was
I look forward to it. Good.
Thank you very much.
Au revoir.
Au revoir. See you. Take care.
Okay.
Goodbye. Goodbye.